Let's talk briefly about practical weather. There won't be terrible amount of questions on the FA written test for weather, but still, we do want to have some awareness of it and some cautions. There are some questions. So, in your mind right now, what do you suppose might be the most hazardous conditions to fly your drone? Just give it some thought. Um, Remote pilot commands must utilize weather. That's part of our job, is to utilize weather resources to build an overall picture and assessment of the weather to make some decisions about whether or not to fly. This is probably one of the most critical aspects of all um, pilot decision making, period. The weather sources discussed in the first semester here will help guide students as we continue to prepare ourselves for the written test and for professional drone flying. Um, there's a variety of sources out there, METARs, TAFs, different places to get the weather, get it online. Aviation Weather Center is one right here. You can gain an incredible amount of information. You Once you get a little practice in this, you can out forecast the local weatherman. Okay, that's the same sources they get it. They just condense it so that they can transmit it in a brief way for just the regular average on the street guy. But for us, it's important because we make certain promises, we have certain contracts where we have to do certain jobs. We need to be able to check the weather in advance, especially forecasts, but even on the day of the weather of the uh, operation, we need to be able to find out what the kind of weather is going to be. So we're not wasting our time um, fumbling around, just eyeballing the weather and thinking whether or not that's good or not. So anyway, um, just imagine you're a UAS pilot who needs to photograph the college from all sides, right here. Okay, what weather resources might you check, right? Well, if it's a very local operation, like you here, looking out the window and telling, but see, you may not live here. You might have to travel, so you wouldn't want to check um, the current weather report for this area. How strong is the wind? How high? How low are the clouds? Or perhaps if the operations plan for 5 hours from now, you might want to include forecast as well. Is it going to get better or worse? Is it going to, may not be a whole lot of wind right now, so the report may be rosy and happy, but in the near future, it may get quite a bit worse. Um, you know, yeah, obviously, go outside and look out the window. That's clear. But you could search nearby airport weather reports or use other weather resources, prog charts, etc. Even non-aviation resources could be used as well. Forecast to there, terminal air forecast, aerodrome forecasts, winds aloft, all of these things. And again, TV, radio broadcasts as well. So how do you determine whether I should go or not go? What are your personal standards, right? I mean, depends on how much experience you have. I mean, the 25,000-hour Delta Airlines captain probably has different standards than the student pilot. Well, I hate to say this, but as you're first starting out, you probably ought to be a little bit conservative about your estimation of how to handle the weather, right? Obviously, there are some regulatory issues as well. What is the distance? How close can you come to a cloud, below a cloud, right? You've still got that regulation says you cannot fly any closer to a cloud than 500 feet below it or 2,000 feet horizontally from it. And what kind of visibility you need. Those are things that weather reports will give you. 3 mile statute mile visibility from the control station is required. Winds, temperature, is it going to rain, etc. So there's all kinds of other issues as well. So weather is a very important issue. The FAA requires us to do a pre-flight inspection, but that includes getting all available information, obtaining all available information, which includes weather. Okay, if you take off and there's so much wind that it blows your drone across the road and it hits a moving vehicle, you can't say, I couldn't control it. The wind was too strong. No, it's your fault for not checking the weather and making sure that you could perform the operation safely, right? You are pilot in command, which implies responsibility for everything that happens, including your failure to check to see if the wind was going to be too strong, etc. So pre-flight, when we say the word pre-flight, we sort of imagine, check to make sure the machine is okay, the propeller blades are attached and the batteries charged and all that stuff. But it also includes checking the weather. This is an important part of your duty as the pilot in command, certified pilot in command. So a comprehensive pre-flight, not only checking the aircraft and checking yourself for that matter, making sure you're not fatigued or have not had adequate sleep or other things, also includes checking the weather data. Atmospheric stability, winds, surface heating, visibility, cloud layers, a few things. And this is a review somewhat, but these are basic things that we learned earlier. Um, Sun is the ultimate driving factor of all weather and associated patterns and phenomena. Due to the Earth's curvature and geography, the sun heats the Earth unevenly, right? That's why there's a North Pole and it's got ice, and then we have the equator where we're sweating profusely. Okay, Earth's curvature and geography, the sun heats the Earth unevenly, creates this heat imbalance, which creates these large air cell circulation patterns in the atmosphere, which we commonly refer to as wind, basically. And wind is a good thing. Warm air rises faster than colder air or cooler air. It's all relative. But this creates these areas of atmospheric instability. When rising warm air ascends through the cool air above it, the instability creates large systems of pressure variations. Rising air is generally associated with low pressure systems and falling air associated with high pressure systems. So you see these circular areas. Um, this is a very simplified diagram. These large cells here, they're actually divided up into typically 3 cells, but with the same characteristic. Warmer areas rising and then moving over to equalize the pressure differential to the low pressure areas. Yeah. Uneven heating creates the heat imbalance. Heat imbalance causes circulation patterns, which we call wind. Warm air rising through descending cooler air creates instability. Okay, so in the aviation, weather, and national airspace system classes, you will learn more about how weather and density altitude affect the aircraft, but still, we just want to touch on some of these things at this point. So another part of the semester will be more specific, but here. So due to the size of our aircraft, they are, after all, small, uncrewed aircrafts, right? They are small and more susceptible to wind, or actually all weather phenomena, especially turbulence and wind, will affect the small UAS to a greater degree than it might a regular larger airplane. All right. So, but anyway, just like manned aircraft, UAS operate in a low density altitude will have improved performance over those operating in a high density altitude. So that will include more power available for thrust and climb and better fuel conservation. Surface heat. Now we saw the global surface heat, right? The North Pole, less surface angles, but that's macro weather. Micro weather here is local, very local here, and we see again this picture here. On this side, surface heat and wind. We see the angle of the sun hits the earth, warms up the ground, which warms up the air above it, and as the air is warmed, it rises. So we have these little areas of turbulence on this picture here, typically plowed fields, darker things, or pavement are going to absorb more solar energy, warmer. And yeah, I mean, you've walked barefoot on the pavement. Typically, it's hotter. You get your feet got sort of hot. You step on the grass, it's cooler. Okay, you get the idea, right? But as that heats up the ground, it heats up the air above it, and the air rises. So we have, if your drone's flying across the surface of the ground, it's going to have some rising air. It's going to go up a little bit. It's going to have a lot of. That's basically what turbulence is. That's part of what turbulence is. Part of what turbulence is the wind as it blows over objects and whatnot. And sometimes turbulence is um, involves a rain shower or a thunderstorm. This could just be a regular rain shower. These rain shafts, as it starts to fall, will drag air down with it, and even though the moisture isn't going out, moisture just falls straight down, hits the ground typically. The air, as it's being pulled down, has these little rotational waves that push out from it. So even if you're near a rain shower, you may have a large increase of wind, which causes turbulence or can be more serious. We'll get into that as we talk about thunderstorms, but just to give you an idea, this could be just a rain shower that would cause this downdraft here. Other things are, as the wind moves across the surface of the earth, it will uh, buildings or hills or even trees will cause turbulence afterwards, following. So we have the wind blowing up, which is great. It's giving you some uplift here, but as the air goes across here, it tends to be turbulent on the downwind side of an obstacle. And this is just a mountain. It could be a building, it could be a tree, it could be anything is going to cause some turbulence on the downside of the wind. And the turbulence increases with the velocity of the wind. If there's a lot of wind, it's a lot of turbulence. If it's less wind, it's not, maybe not as much. Okay, so we have limitations um, as far as wind as well. There's a concept here of the true airspeed of an aircraft as it moves and the wind speed, the relations between the two. Um, in this case, as we're flying, if there's significant wind, you have to add the speed of the aircraft to the speed of the wind in order to tell you what the ground speed is. And that's an important issue. Let me do one more bit. Okay, so if you're flying with the wind, you would add the wind speed to it. So you're moving at this little diagram here, 25 miles an hour. Let's say your drone flies at 25 miles an hour. If you have a 5 mile an hour wind blowing in that direction, your ground speed is going to be 30. Great, fantastic. But if you're flying this way at 25 miles an hour and there's a 5 knot wind blowing against you, your ground speed, or GS, is going to be 20. I think I said 25 here, right? 20. So it's going to be slower. Okay, still not that big a deal, but it does become a big deal. Let's see if I can erase this and start from scratch. Yeah, I can. Let's say that we have a strong wind. Okay, let's say your drone, you've got a Tello, right? Rise Tello. It can only go 10 miles an hour. What if you have a 10-mile-an-hour wind? So you're traveling this way, max speed 10 miles an hour. The wind is blowing this way at 10 miles an hour. You're not going to move. Okay. You're not going to be moving in that direction anyway. You'll be able to turn around and go the opposite direction, and you'll be doing 20. So ground speed and airspeed are not the same. You have to either add or subtract the wind, or typically we don't fly exactly into the wind or exactly with the wind. Some angle, it's going to be a certain percentage of that. Okay, the problem becomes an issue of running low on battery. If we're flying in a distance away, and wow, got my papers all messed up here. We're flying a distance away, and we're flying with the wind and lets the wind carry us. We go a good ways away, still within line of sight, of course. We go a good ways away. We fly for 25 minutes. Battery low, signal comes on. It's time to come back. Well, now we're fighting the wind. We might possibly get ourselves in a situation where you could not retrieve the aircraft. There'd be too much wind, and you wouldn't have enough energy left with your battery to return home. So we want to keep that in the back of our mind, basically. If we're going to have a mission like that, we might want to position our takeoff position, return to home position, so that we fly into the wind first, do our mission over there, and then you'd have the wind to help carry you back. It's a matter of energy management, basically. Okay, I made a mess of my papers here. Wow. Okay. Wind speed affects the ability of the UAS to return to the pilot's location, of course. Okay, we have other limitations. This is slide number 12. Battery life and the wind. I just mentioned that, right? The UAS battery will deplete more quickly when struggling into the wind, or even if it's turbulent, maintaining position, right? Remember now, the motors are constantly changing in a multi-copter. The motors are constantly changing RPM in order to stay stable. Well, if it's turbulent and the drone is jumping around like that, it's constantly changing the motors faster, slower, faster, slower, faster, slower. It's going to burn energy quicker that way as well. So turbulence, wind is basically a kind of turbulence. That's going to reduce the energy that you have available. And you do the same thing when you act crazy and fly erratically. You're inducing that yourself by using more energy that's necessary, and you shorten the length of the flight by doing that. Okay, enough of that. Okay, thunderstorms. Okay, there are 3 things necessary for a thunderstorm. This is the most severe weather event that you're going to face. Whether you're a drone flyer or whether you're a golfer, okay, doesn't matter, or someone out fishing, you're going to be concerned about thunderstorms. So listen up. There are 3 things necessary for a thunderstorm. You have to have water vapor. In other words, it has to be some humidity. You also have to have atmospheric instability. Remember, we talked about that when there's warm air rises. So if you have warm air underneath and cooler air above, and the warm air rises up through the cooler air, it's going to be there's going to be some atmospheric instability. And then you need some kind of a lifting force. Lifting force could be a number of things. We'll talk about that in a second. But you need those 3 things. Surface heating, some kind of lifting. So there's those 3 different ways of having a lifting force, right? A lifting force could simply be that there's an area that is warmer than the surrounding area. That's necessary. Could be mechanical lifting, though. If there's wind and then there's a mountain, it could be the wind blowing up the mountain. So let's see if I can make a nice little drawing here. This is the... That's the wrong color, I guess. Try that color. Okay, we got that mountain. So there's a mountain here. And the wind is blowing across here as it's pushed up. That's lifting force. That's causing lifting force. So you're taking this warm air and pushing it up through the cold air. Or this could actually be a building. doesn't necessarily mean to be a mountain. It could be a building, whatever. Whatever's pushing that air up uh, could induce this lifting force. Or it could be a frontal system, and we'll talk about that in a minute. So, from this point, let's talk about how they form. Um, we have these the three sections of how the FAA understands, and how it's a really good way to understand how thunderstorms are formed and how they evolve. Right? They start out with phase one, which is the cumulus stage, 3 to 5 miles heights. We have some uplifting, whether it's a mountain uplifting or just temperature, could it be a frontal system, whatever. So we have air rising. As the air rises, the temperature of the air, adiabatic forces causes the temperature of the air to drop, and as the temperature of air drops, it can gets to a point eventually where it cannot hold the same amount of moisture, and the moisture turns into something visible. That's what makes the cloud, and eventually it gets cool enough to where it actually starts raining, and that's where you get the second stage, mature stage, where rain starts falling. So you have these still have updrafts. So you have updrafts in the cumulus stage, which is what the word cumulus means. In a mature stage, you have updrafts where the air is being pushed up and cooling, and then you also have these downdrafts where the rain is falling and pulling the air, some of the air molecules down with the rain. So this is a lot of turbulence in there because you have these two different opposing air movements. And then we have the dissipating stage where it's run out of energy. It's the rain has perhaps cooled the ground underneath it, or for whatever reason, it's run out of energy and it's almost all downdrafts with rain. Okay, so 3 stages. You need to memorize that: cumulus stage, mature stage, dissipating stage. Again, cumulus stage, continuous updrafts creates that low pressure area, and thunderstorms gain some vertical development. Mature stage, updrafts, downdrafts occur. So we have significant wind shear and turbulence. Rain begins. Dissipating stage, that's the final stage, characterized primarily by downdrafts as the thunderstorm tops begin to descend. They tell me that a thunderstorm only lives for like about a half an hour, 45 minutes, then it dies off. The thing is, if the atmospheric conditions are right, then as one thunderstorm reaches the mature stage, another thunderstorm is at the cumulus stage, and then another one will be at the dissipating stage, and they'll be continually popping up thunderstorms, and it will appear to us on the ground as like it's one thunderstorm that lasts for days and days and days. But typically, um, they're not supposed to last that long. The most severe kind of thunderstorm is called a squall line thunderstorm, where it's typically, but not always, associated with some kind of frontal system, but it'll it'll be a line of thunderstorms which will um, cover large areas. That's Wisconsin, right? Covering pretty much from one end to the other of a whole state. And we'll get those in Georgia occasionally. And this is typically where you'll get thunderstorms. Well, you'll get tornadoes out of these. They can happen under a supercell, single cell. Yes, it can happen, but often it's related to a squall line. There's no way to get around it. You pretty much have to, if you're in a manned aircraft, you need to get on the ground, find an airport, land, and go inside and have a cup of coffee because you can't get around them. Airliners sometimes can get above them, but some of these thunderstorms are very high altitude and can spew hail profusely. And we have access. As drone pilots, we have access to radar information. NOAA has these radar images that you can access. So, if you're maybe in perfectly clear weather and you see this line here a few miles, it's usually pretty fast moving, 35, 40 miles an hour. So it'll arrive, by the time you get out to your job site, and get ready to launch your drone, it could be very close. So anyway, forecasts are very helpful in these cases. Okay, so um, obviously the shearing of high winds is one of thunderstorms' greatest threats. Can cause extreme turbulence, can cause structural damage to any aircraft and loss of control for any aircraft. While severe and extreme turbulence can potentially destroy a UAS, an even more significant threat, really, both to the aircraft and the pilot, is lightning. Thunderstorms always produce lightning to some extent. The amount which is determined, by the storm severity, really. If you observe lightning or hear the thunder, you should safely recover the aircraft and take shelter. Again, we have the ability to, even on your telephone, obviously on your telephone, since you're in the field, to check the forecast and check the weather radar and check if the airport's nearby for any kind of situation where thunderstorms might be likely. And we did do that. Oh, let's see here. Okay. Lightning is a threat. Recover the aircraft. Okay. Um, yeah. Okay, so as far as lightning is concerned, might be good to have a rule of thumb for how far away it is. So you see lightning flash, you start counting, and then you count until you hear the thunder boom, and then you take that number, how many seconds that was, divided by 5, and that gives you a rough idea of how far away that lightning strike was. Just remember that lightning bolts can go, last I read somewhere it was within, it could be up to 10 miles from the actual thunderstorm, the lightning might hit the ground out there. So yeah, that would be, you'd definitely find shelter before that, because lightning is and it really, we're not too much concerned about the drone. We're concerned about you getting hit by lightning. It happens all the time with golfers, but we want to try to avoid that if possible. Oops. Yeah, there's the again, count seconds between the lightning and scene, and resultant thunder divided by 5, rough distance in SM is statute miles. Okay, next. Okay, so switching gears from that, clouds, visibility minimums. We have this diagram from the FAA. Whenever unmanned aircrafts are being conducted, visual line of sight must be maintained between the crew and the UAV. Remote PICs are ultimately responsible for separation from other aircraft, which can only take place if the aircraft are spotted in time to avoid them. So before launch, we must determine the visibility from the ground control station. In fact, it needs to be at least, 3 miles or greater. In addition to that, and this coincides with manned aircraft as well, UAS must not be operated any closer than 500 feet below or 2,000 feet horizontally from the cloud. And I get it, from the ground, it's difficult for an operator to judge cloud altitudes and exact visibility. I get it. Unlike manned aircraft that use airports where current weather conditions are available from, ASOS or AWOS automated systems, UAV operators tend to be flown in areas without those systems. So we're the ones that have to sort of gauge that. And the FAA is generous. I mean, they're not, they're expecting us to have to use some common sense and some judgment with that. You go on YouTube, you find drone videos flying through the clouds. Well, obviously they're not thinking about this, and it's obviously a violation, and the the FAA is going to violate them, no doubt about it. But um, that's just irresponsible, and those are the kind of people that are going to cause the FAA to make more rules and restrict our ability, our freedom to fly. So that's just the way it is. So anyway, so the diagram is pretty accurate. It's showing a manned aircraft, of course, but that's what I'm saying is that that's their same criteria. And I don't know, I'll elaborate just slightly, just for a second here. We don't have a whole lot of time. We're running out of time, but as manned aircraft are descending, they'd come down. They don't just come straight down. They come down at a nice shallow angle. So what we're saying is that this gives us, if we're 500 feet below the cloud layer, that gives them time to see us if they're coming through the clouds, but also gives us an opportunity to see them, right? Now, if they're diving straight down, then there would not be enough time. Same, okay, eraser. The same thing applies. Nope, that's not it. Hang on. Yeah. Same thing applies to the through the cloud thing. Let's see if I can do this. That's a cloud. That's a cloud, believe it or not. So the aircraft is flying along. They're allowed to fly, instrument flight rules. They're they're allowed to fly through the cloud there. So he's staying at the same altitude. He's flying along like that. Well, they're doing the one that's coming down to the clouds is not coming down that fast. This guy, he's traveling, could be flying at 250 knots. So 2,000 feet gives both them and us time to see them. So that's why we've got to be 2,000 feet from the side, because there's less time for us to react and for them to react as well. Okay, let's not belabor that. Let's keep moving here. All right. In any case, VLOS must be maintained. And yes, the PIC is ultimately responsible for its separation from aircraft. We are not allowed to let them or to force a manned aircraft to alter course. 3 statute miles. Distance from the cloud, 500 below, 2,000 feet horizontally. Okay, so estimating, yeah, I get it. It's difficult, but we need to have enough visibility so we can avoid manned aircraft. Probably the best way to do that is to have a rough idea about, look off in the distance, what's something that's around 3 miles away, maybe a lighted tower or something like that would help us to judge that. Still not easy, but you just need to be conservative about visibility anyway. Obviously, never fly over clouds and never lose sight of your UAV. I mean, it happens. You lose sight of the UAV, then you need to get it, retrieve it as soon as possible. Retrieve it to the point where you can see it again. And that's, strobe lights, anything you can use. If you have there's no medical requirements for vision testing or anything like that, but if you have difficulty visually, then you're going to be restricted in distances. Or you can employ a visual observer. Okay, let's talk about fog momentarily, because this does, obviously it's going to reduce your visibility. So we need to understand, how does it form? Well, it forms when air cools to its dew point or its saturation point, right? Either air can cool to that point, or you can add moisture to the air, to cooler air, and it will turn into fog, right? So we have different kinds of fog, but that's basically normally forms when in the morning or in the evening when the temperature drops. It's pretty typical, right? The earth is being heated by the sun, so the ground is warmed, and it warms the air above it. And the warmer the air is, the more moisture it can hold. So when the sun goes down, now the earth starts cooling off, and that cooler air or cooler ground cools the air above it, and if the air above it is saturated with moisture, it turns into visible moisture, fog. Fog can form very rapidly and can definitely impede visibility. Or if you've been driving early morning or in the evening, yeah, you can see it. It's definitely. So we need to make a habit to check the temperature and dew point as part of our pre-flight weather routine. Um, on the weather reports, whether it's written or hearing it on the AWOS transmissions, it'll be temperature and then dew point. When they come together, it's very likely that we're going to have some kind of fog. And if we know that it's close together, we know that that's a possibility that there may be fog. Well, we have, I will briefly mention 3 different kinds of fog. There's radiation fog, um, which is when the ground cools, like at night, cools the air around it to its dew point. I already mentioned that. Advection fog forms when warm, moist air is moved by wind over a cooler area. So, yeah, if you had, yeah, in the wintertime, I suppose, if you had snow on the ground and you were near a pond or a large pond, I guess, or the ocean, so we have warmer water. If the air blows this warmer water moisture from the water over the top of the colder ground, you could form fog. That requires some wind. Then we have what they call upslope fog. Uh, when you have upsloping um, ground, I will draw that as well. This is the Earth, and this is a mountain here, blah, 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 blah. You've seen this diagram several times already. Here's the wind blows up. Oh, as it goes up, adiabatic forces, temperature drops as the air is. Why does it drop? It drops because the air is expanding, right? As it gets thinner, right? The air is thick on the ground, and as we get higher, it becomes thinner. So as the air gets thinner, the molecules move further apart. As they move further apart, they cool off. And as they cool off, the moisture that it's contained in that air becomes saturated and turns into fog. That requires wind too. If there was no wind, it wouldn't do that. So those are the 3 kinds that you'll need to know for the test. Yeah, okay, we'll continue on. Okay, so review. How many miles visibility? Oh no, I'm sorry. The first one says cloud clearance. You have to be 500 feet below the clouds or 2,000 feet horizontal, right? What's the visibility necessary? 3 miles. If we were in class right now, I'd be asking you the question, you'd be answering them, but I'm going to answer them for you. Is it ever acceptable to fly an aircraft above the clouds? No. Although you can go on internet and people will argue about this, but since there's not listed as above, how high can you fly above the clouds, the implication is the FAA is not approving that, but I don't want to get in that argument. What could occur when operating a UAS on the upwind side of a large object or terrain? Turbulence. Well, there'll be an updraft on the upwind side. In other words, where the wind, this is upward, by the way. Okay, large object. There's there's a tower, right? And the wind is blowing up there. There's be an updraft, okay? On the downwind side, there's going to be turbulence down here. Okay. Well, I've just covered up my slide here. Let me do some erasing here. Okay, here we go. What makes a UAS aircraft performance capability is particularly important on a windy day, as you can fly with the wind and exceed the ability to have enough energy to get back to home point. You're going to have to go out and find the drone because it's going to land somewhere in a field far, far away, and you'll have to find it, but you don't want to have to do that. Nah, you don't want to do that. Okay, I'm going to let you pause. We're almost done with my video, but not quite. pause it, watch this video, or come back to it, whatever, but it's a QR code, watch it. He talks a little bit about how to fly in cold weather. Well, it's not totally relevant too much to Georgia, although we get there's some, when it does snow and it's very cold outside, we get some really fantastic video photography opportunities. So I suggest do watch that. It's a pretty good video. Okay, keep going here. We have we have weather sources, multiple sources that are all freely available. Um, but again, it's our responsibility to form a weather picture, and that's part of our pre-flight obligation as professional pilots. We have 1-800-weatherbrief.com. That's also a phone number, by the way. You can call the phone number and talk to a human being, and they will actually, they're very lonely there. Nobody ever talks to them, and they'll give you a whole weather brief. You tell them who you are, where you are, what kind of airplane you have, and what time you're going to go fly, and they'll tell you more than you ever wanted to know about the weather. And they can also tell you about restricted airspace and different things like that. But you can just go online as well. Some of us would prefer just to go online. Aviationweather.gov is another really good one. I probably demoed it already. So either one of those is a good source of weather information. And there's a plethora of information there. I mean, not only reports, but forecasts, etc. So there's a ton of information there that's stuff that we can use to help us. Okay, we've got several scenarios. I'm not going to get into these because that's just something we probably need to do in class. So I'm going to pass on this. This first one, they're all sort of similar to this. Scenarios: arrive at the launch site, you take a note. That's supposed to say note. Take note of a tower on the sectional chart that is 700 feet above ground level. It's an overcast day. Clouds are barely touching the top of the tower. Your mission requires you to fly at the maximum altitude for UAS operation. Okay, well, in this case, if the clouds are at 700 feet, that's what that implies, the top of the tower. We know the tower is 500 feet or 700 feet. We can only fly 500 feet below that. So 700 minus 500 is 200 feet. So we're only allowed here. Does that make sense? I want to make sure it makes sense to you guys. 700 feet minus 500 feet below. So we can only fly 200 feet above ground level. We can only fly 500 feet below clouds. So that's the scenario here. Okay, does that make sense? So we should think through those kind of things. Just remember that, and this is a sort of a typical question too on the test. So anyway, thank you. I believe that's it, except for a few more scenarios that we can do in class. Long video, sorry, but this should be helpful.